Here for example 3, it says to analyze your graph of r equals 4 cosine 2 theta. So we are going to have to graph this. So when you make your table of values, it's like we have in the past. So we're going to do your first and your second quadrants, and then we'll do our third and our fourth. So we're going to start with 0, maybe 0, pi over 3, not pi over 3, how about pi over 6? Pi over 4, pi over 3, so this first quadrant. Then we go pi over 2, 2 pi over 3, the 3 pi over 4, and 5 pi over 6. So that will take care of your first and your second quadrant. So then let's go into pi, 7 pi over 6, 8 pi over 6, which is also known as a 4 pi over 3, whoops, let me undo that. And once again, I forgot the 5 pi over 4. I think I did that last example. So there's 4 pi over 3. There's quadrant 3, so we go 3 pi over 2, and then we have a 5 pi over 3, a 7 pi over 4, and 11 pi over 6. Now when you plug these values in, you are going to have to multiply 2 times your theta, then find the cosine of that. So if we say plug a 0 in, 2 times 0 is 0, cosine of 0 is 1. 4 times 1 gives us a 4. So our first point is that in the direction of 0 is 4. Then we have to go through pi over 6. Well, 2 times pi over 6 gives us a pi over 3. So the cosine of pi over 3 is a, wait for it, 1/2. So if we have 4 times a 1/2, we get a 2. Then we want to plug in, I'm sorry, that was totally incorrect. I was thinking of pi over 3. Oh wait, no, that's right. Alright, so then we go to pi over 4. So you plug a pi over 4 in. 2 times pi over 4 is a pi over 2. Cosine of pi over 2 is 0. 4 times 0 is 0. Pi over 3 times 2 is 2 pi over 3. Cosine of 2 pi over 3 gives us a negative 1/2. So we have a negative 1/2 times a 4 gives us negative 2. Now let's plug in pi over 2. 2 times pi over 2 is just pi. Cosine of pi is negative 1. Negative 1 times 4 gives us negative 4. 2 pi over 3 times 2 is a 4 pi over 3. So the cosine of 4 pi over 3 is a negative 1/2 times 4 gives us negative 2. Looks like I see a pattern here. So I'm going to guess this will end up being a 0. 3 pi over 4 times 2 gives us a 6 pi over 4, or a 3 pi over 2. Cosine there is 0, so we get a 0. 5 pi over 6 times 2 is a 5 pi over 3, so the cosine of 5 pi over 3 is a 1/2. 1/2 times 4 gives us 2. That's a 2. Not a cursive Q. Plug in a pi. Cosine 2 pi. 1. So you get a 4. And then you have a 7 pi over 6 times 2 gives us 7 pi over 3. So 7 pi over 3 is the same as a pi over 3. Cosine at pi over 3. Right, if you think about where 7 pi over 3 is, that is coterminal with pi over 3. So that's the same thing as pi over 3. So the cosine of pi over 3 is going to be a 1/2 times 4 is 2. So what's going to happen is we're going to end up and repeat almost the exact same thing we did before. Let's plug a 2 times 5 pi over 4, it gives us a 5 pi over 2. Well, 5 pi over 2 is coterminal with pi over 2. Cosine of pi over 2 is 0. and you're just going to end up repeating all of these same values that we did in the other column. So let's plot these points. So we go in the direction of 0, and we're going to go a distance of 4. So let's make each of these a half. So half 1, 1.5, 2, 2.5, 3, 3.5, 4. So we go 4, 0 in the 0 direction. There's your first dot. In pi over 6, we're going to go 2, so here's another dot. 0 at pi over 4. At pi over 3, we're going to go -2, so pi over 3, instead of going up here, we're going to go down to half, 1, 1.5, 2. Go in the direction of pi over 2, which is up, but we need to go -4, so that's actually going down over here. And then we're going to get a negative in the direction of 3 pi over 4, which would be up here, but we need to be going this way. So that's going to end up being a I can't even see what I'm doing here. Pi over 2, we did that one. 2 pi over 3. 2 pi over 3 is, oh sorry, I did this in the wrong order. So here's what that would be. And then 3 pi over 4, we'd have 0. 5 pi over 6, we're going to do a 2. So half, 1, 1/2, 2. And then we have, actually we don't have this point right here. Then we go over here to, in the direction of pi, we go 4. So we're going to go out here to 4. 7 pi over 6 is a 2. Oh, it's not there. Right here. 0, back to 0. Then we have a, in the direction of 4 pi over 3, which would be down here, we're actually going -2. So that means we're going to be going 1. Here's that. And then we have 3 pi over 2, which is going down. We go actually up because it's the -4. 5 pi over 3, which would put you at 300, but you're actually going to go -2 over here. And then we have 7 pi over 4, you go back to 0. And then 11 pi over 6, we go a distance of 2. So if we start with our first point, 4, 0, and draw in the direction that we plotted our points, you end up getting, oops, I am missing a point over here. You end up getting this pretty little shape, which curves back through, goes over here, down and through, back up through here, hits the top, comes back down. This is called a 4-petal rose. So look at your equation, look at what you think would give you a rose. What's different from examples 1 and 2? It's this little 2 right here. So that is how you graph a rose. Whoops, I didn't even finish it all the way, sorry. Goes down through, here's the 4th petal. Now it looks better.